In the diagram below, a ball bounces indefinitely along the path modeled below. The ball starts at A, where it is catapulted into the air before bouncing for the first time at B. The horizontal distance BC is 3/4 of AB. So this is 3 over 4 of AB. And then CD is 3/4 of BC. 3/4 of BC. This pattern continues indefinitely. So it means AB is our first distance, which is going to be A, the first term. And then to get to the next term, you always multiply by 3 over 4, meaning that 3 over 4 is the common ratio. Right, each bounce is modeled by the equation y is equal to -1 over 2 x minus p squared plus q. If the ball continues to bounce, it will eventually converge with the horizontal 16 meters from point A. Is converging with the horizontal 16 meters from point A, meaning that if we add these distances, when the ball bounces indefinitely, we'll get 16. So meaning that 16 is the sum to infinity. Okay, so the question says, determine the length of AB. AB, like we said, is our first term A, and 16 is sum to infinity. So we use the sum to infinity formula. Sum to infinity is equal to A over 1 minus R. Right, sum to infinity 16 is equal to A, that is our AB, over 1 minus 3 over 4. Right, so 1 is like 4 over 4. 4 over 4 minus 3 over 4, that is 1 over 4. 16 is equal to A divided by 1 over 4. Dividing by 1 over 4 is like multiplying by 4 over 1. So it's like A times 4, which is 16 is equal to 4A. Then we divide both sides by 4. 4 is equal to A. Therefore, AB is equal to 4 meters.